Good evening, Dr. Hassan. Uh, the title of my project is Modeling of Brake Pedals. And as we all know, the most important, or one of the very most important components in making a vehicle are the brakes. What are the functions of the brakes? The function of the brakes reduces the speed in a vehicle. And we all know that brake pedals are being used in virtually every kind of automobiles, in cars, in trucks, in buses, in motorcycles, in bicycles. But this particular one that we're talking about here is the modeling of automobile brake pedals. And there's the main reason why I'm interested in this project, because I know virtually all motors and all cars use them, and irrespective of different masses and lengths, they all have the same function, and they all have different length and different forces being applied at different times. The application of this project has evolved in so many areas, considering the fact that some people have done that this design before, simulating it as well, making it work in different areas. The works that have been done before on this, something I'll reference to Robert France, who has done something on a brake system using TTPC protocols. What information is missing from the previous works they've done? The work that they've done before is more of electrical, but in this particular one I'll be doing on this project here is more of mechanical. And what we're looking at here in the mechanical part of it is the potential energy of a spring, the amount of force that's been applied at the end of the pedal, the distance, the length of the pedal from where the brake is being attached inside the vehicle to where the force has been applied, the length of the where the brake is being attached inside the vehicle, and also to where the spring is. What we'll be doing here is that we'll be taking a moment at where the pedal, where the force has been applied on the pedal, and also a moment to where the spring has been attached. We'll be able to, by taking these moments, we'll be able to find out the sum of forces all around from the end of the pedal to the spring. Now, what I'm planning to obtain from this project is get the natural frequency, the mathematical model, then go ahead to get the Laplace transform, also taking from S domain to the time domain. Now, for us to do all things for the project to come into play, we'll set our equation, starting from the equation of motion. We'll take the equation of motion, which is the methodology of how we're going to run this project. We'll take the equation of motion, sum all the forces at the moment, from the moment of where it's been attached to where the force has been applied upon, take a moment from where it's been attached also to where the spring is. When we do that, we try to find the angle, the natural frequency. From the natural frequency, we take the initial conditions, take the Laplace transform of that equation. Then from taking the Laplace transform of that equation, we'll also take it back to the time domain. The reason why we'll do it like that is by the time we put this equation back into our MATLAB and simulate this equation, it should be able to spell out our step response. And what this thing is trying to do for us is that at every moment in time when that brake is being applied, when the force is being applied on the brake, it's going to send a signal into the vehicle, and a mechanical and electronic signal into the vehicle, which helps slow the speed of this vehicle. This particular design, this particular model of this brake pedal can be used in any form of automobiles. What it does is we have different kind of variables which will be used here. We have the length of the pedal, we have the amount of potential energy that will be in the spring, we have the amount of force that will be applied upon the pedal for the brake to work. Now, at every point in time, if you change any of these variables to how you want it, the same model can be used in any form of vehicle, be it a Mercedes-Benz, be it a Volvo, be it a Honda. The most important thing is that the modeling of this brake pedal is something that can be used alternatively in any form. I hope that at the end of this, we will also understand the reason why this is being done in the mechanical part of it. Since the electrical part is being done using the TTP protocol, this is the mechanical form of designing a brake pedal. Thank you very much. I hope you enjoyed the presentation.